Okay, so 6.2, I kind of want to pose the question to you. Here's the empirical rule in that picture, but how do we find the area underneath the curve if the number of standard deviations isn't a whole number like 1, 2, or 3 away? Well, kind of an issue, so I'll show you a way that this can be done by taking and using what's called the standard normal curve. We're going to convert raw scores, so numbers that have their individual means and standard deviations, into a z-score, which will be a distribution of the normal curve that's got a 0 average and a 1 for a population standard deviation. What does the z-score look like? Well, we would like to be able to compare observations from different normal curves. So if I've got one, say, measured in feet and the other one measured in meters, I can compare them if I standardize them. Observations come from different normal distributions. Maybe we've got a population of students here versus a population of students in Bismarck that have both follow the normal curve, but we want to compare them. And it's kind of standardizes the observations to make some suitable comparison. I know they do this with my children. When we go to the first month, 2 month, 3 month, all the way through like year and a half checkups, they've got z-scores associated with their head circumference, their height, their weights, comparing them to different kids. A z-score is a number that of standard deviations between a measurement and its mean. The z-score used to make comparisons of measurements from different distributions. Z-scores can be positive, negative, or zero. Zero means they're smack dab in the middle. Positive indicate that the measurement was above the mean. Negative indicates that the measurement was below the mean. We have z-scores greater than 3 or less than -3. That's very rare. And the reason why that is that we've got numbers that are extremely large or small. They're kind of in the no man's land, a really small part of that curve. Okay. So a z-score is taking your original data, subtracting the population mean, and then dividing by the standard deviation. Okay, these have no units whatsoever to them. There's a table in the back of the book. I believe it is the back binding that's going to be used a lot for these. But let's use this pizza delivery guy as an example. Let's say the amount of time it takes for a pizza delivery is approximately normally distributed with 25 as your mean and standard deviation of 2. We're going to convert 21 into a z-score. So 21 minus 25 divided by 2 works out to be -2. Now the z-score of -2 means that we are at a delivery, that 21 value is 2 standard deviations away from the mean, but it's in the left direction or below the mean because of that negative value. Now this is one that we could actually just stick to our empirical rule on, but we don't necessarily have to. Another way we can do is we can reverse this. If you know what the z-score is and the mean and standard deviation, you can work your way kind of backwards to figure out what the original raw data was. And I just took the formula for z equals x minus mean divided by standard deviation. I did a little bit of algebra to get x by itself. Okay, so how does this work out? Well, let's use the same pizza information, but this time the z-score is 1.5, and I don't know what the original time was. So x, the original time, is equal to the z-score, 1.6, times our standard deviation of 2, plus the mean of 25. It works out to be 28.2. So that means that the delivery time was 28.2. Now, z here is a positive z-score, so my final answer should be above my average of, well, here, 25. And it is. It's 1.6 standard deviations above that 25. Okay, z distribution, so here you go. I kind of alluded to this, but the z-score converts them into a standard one where you have 0 as the middle, and z is one standard deviation in, so that's 1 standard, 2 standard, and 3. The importance is that the area underneath the curve doesn't really change. Even though it was from any other distribution, it can get converted into the z table and not lose any of that area property. So here's what we'll do. There's a table in the back of the book, the binding. There's also one on page 822 if you want to use that one. I would just strongly suggest using the one in the very back of the book. For z-score less than -3.499, you're going to get 0 as your area. And anything greater than 3.49, you're going to use 1 or 100%. Okay. The table always gives you the area underneath the curve that's to the left of that particular z-score. And it kind of has a picture of that table to kind of help you out. Remember, anything to the left is on this one table on the left side of the page. It's got all the negative z values. Anything that is to the left on the positive z table is on the right side of your back book. All those z-scores on the left table should be below 50%. All those areas that associate with those z-scores in the other table should be ones bigger than or 50%. So let's say I want to look up a z-score of 1.34. So I'm going to go along the side. I'm going to find the whole number and the tens position. The very first row has all the hundredth spots. So this is 1.34. I kind of work my way down and I get a positive 0.9099. So to the left of the z-score, 1.34 is 0.9099 of that curve. If I want to look up z is equal to negative 2.67, I'm going to look down and find negative 2.6, but now I'm using the other table with all the negative z-scores. Find 0.07 as my 100th spot. Kind of go work my way in and down and get an area of 0.0038 rather, which is a very small area because remember, we're always going to give the area to the left or be given the area to the left in those tables. Okay, so again to the left and again to the left. So you find that negative z-score, it's everything below, so smaller. Find that z-score, everything to the left, so bigger. Okay. When we're trying to find the area between two z-scores, so this red arrow is my desired. If I look up z1, this z-score over here, that would be my negative area. This z2 would be my purple, or again, not purple, rather, my teal arrow. If I want to get rid of that part of my teal area and just get the red, I'll take the teal one, the large one, minus the small one. Okay, same concept, except for now they're both going to be on the positive side of things. So I'll take the teal area, the bigger one, minus the smaller one. That will give me that area in between as well. So it's kind of like a geometric area question here in a little way. If you want anything to the right, so I want that right area here in teal, that red and teal one will add up to be 1. So you can kind of use that complement area to find that as well. Okay, so here we go. Let's look one up. Z is less than 1.24. So I kind of just like to rough sketch it. So in the middle is 0, 1.24 is there, and I want to find everything down below. That's what I got when I looked in the table. That makes sense to what my drawing looks like. Okay. Do the same thing here. I'm going to do a rough sketch. I've got 0 as one of my z-scores, 1.6 is my other. I look up 1.6 and that's this area. 0 is 50%, so I'm going to have to take and subtract to get that area. And that's 0.4452, which is, you know, kind of a good idea of what my drawing looks like. Okay, same thing here. I'll go with my 0. We'll go negative 2.37. If I'm going too fast, you can always pause this and look up the z-scores. In fact, I encourage you to do that. But 0 is going to be this bigger area of 0.5. This negative 2.37 is going to be the small area. If I subtract them, that's the area that I'm looking for. So here's my answer. That was my answer for the previous one up there. Okay. Anything in between? Okay, 1.88 give me a 0.9699. 1.24 give me a 0.9825. That's going to be a 0.7 or 0.0774. Okay, so again, here's my 0. Here's 1.24. Here's my 1.88. So if I ever look at that curve, it's going to be a pretty small area. And here's my middle. So maybe up there I'll put my 2.39, but I want this direction, so I'll look that up to get 0.99. Go 1 and minus that because again your table gives you everything to the right and I want, or to the left, and I want it to the right. Same concept. but now the z-score is way down below negative 0.43. So if I look up that area, it's right there, but this is the one I want. So I have to go 1 minus that area to get that answer as well. Area underneath the curve. That pizza person again, going back to that idea. So 25 and 27. The mean is 25. The standard deviation is 2. If it helps you, you can go and convert that. But since 25 is the mean, I know that z-score is going to be 0. If I take 27 minus 25, that's going to be 2 divided by 2. My z-score is 1. So I could look up 1 and subtract the area for 0. Sorry, that's a 2. That's my z-score. Okay, but what I'll end up doing is I can use the empirical rule with this one and go and get my 34%. Now that might not be exactly what the table gives me. So you might get like 34.2 or 34.3. I don't have the table with me, so I can't really help you with that. Less than 30 minutes, you get your z-score of 30 minus 25 over 2. So that's 5 divided by 2, so my z-score is going to be 2.5. Okay. Again, I don't have my z-table with me, but if I were to look up that area, I think that is going to be a rather large, and I'm just going to take a guess that it's probably somewhere close to like 90% or 92%. Less than 22.7, so again, you're going to have to find a z-score. You'll go 22.7 minus 25 over your 2, and I can calculate the z-score for you here. So 22.7 minus 25 divided by 2, negative 1.15. 1.15. Yeah, so again, I don't have the z-score, but if you were to look up that table, you'd look that up directly. That is to the left. I bet that's something pretty small, like maybe 20%, 10%, or something like that. But you are definitely going to have to look up the z-score and area for part B and the z-score and the area for part C to get those, because those are not whole number z-scores. Okay, so here's an assignment again I'm going to ask you to do on page 319, 1 through 3, 5, 9 through 49 times 3 means the multiples of 3. It might seem like a lot, but it's a lot of finding z-scores, finding the area underneath the curve, something that you need a lot of practice on to be successful kind of for the rest of the class.